Hello everyone, my name is S.Sathwik. My roll number is 21BQ1A05K0 and I am from 2CSCD. In this video, I want to explain about timestamp based concurrency control. Without any further delay, let's start it. Timestamp ordering protocol. The main idea for this protocol is to order the transaction based on the timestamps. A schedule in which the transaction participate is then serializable and then only equivalent serial schedule permitted has the transactions in the order of their timestamp values. An algorithm must ensure that for each item accessed by conflicting operations in the schedule, the order in which the item is accessed does not violate the ordering. To ensure this, use two timestamp values relating to each database item X. TSX is the largest timestamp of any transaction that executed write X successfully. R_Ts of X is the largest timestamp of any transaction that executed read of X successfully. Basic timestamp ordering. Every transaction is issued a timestamp based on when it enters the system. Suppose if an older transaction T1 has timestamp TS or that is TI, a new transaction TJ is assigned a timestamp TS of TJ such that TS of TI less than TS of TJ. Whenever same transaction T tries to issue a R item of X or a W item of X, the basic 2-revo algorithm compares the timestamp of T with R read and write of X to ensure that the timestamp order is not violated. This describes the basic TO protocol in the following two cases. Whenever a transaction T issues a write item or write operation, check the following conditions. If read operation of X greater than TS of T and if write operation of X greater than TS of T, then abort and roll back T and reject the operation, else execute write operation of T and set write operation to TS of T. Whenever a transaction T issues a R item operation, check the following conditions. If write of X greater than TS of T, then abort and reject T and reject the operation. Else, if write of X less than or equal to TS of T, then execute R item of X, that is read item of X, of operation of T and read to the larger TS of T and concurrent read of X. One drawback of basic TO protocol is the cascading rollback is still possible. Suppose we have a transaction T1 and T2 has used a value written by T1. If T1 is aborted and resubmitted to the system, then T2 must also be aborted and rolled back. So the problem of cascading aborts still prevails. Advantages: high concurrency. Timestamp based concurrency control allows for a high degree of concurrency by ensuring that transactions do not interfere with each other. Efficient. The technique is efficient and scalable as it does not require locking and can handle a large number of transactions. No deadlocks. Since there are no locks involved, there is no possibility of deadlocks occurring. Improved performance. By allowing transactions to execute concurrently, the overall performance of the system can be improved. Let's see some of the disadvantages also. Limited granularity. The granularity of the timestamp based concurrency control is limited to the precision of the timestamp. This can lead to situations where transactions are unnecessarily blocked, even if they do not conflict with each other. Timestamp ordering, that is, in order to ensure that transactions are executed in the correct order, the timestamps need to be carefully managed. If not managed properly, it can lead to inconsistencies in the database. Timestamp synchronization. Timestamp based concurrency control requires that all transactions have synchronized clocks. If the clocks are not synchronized, it can lead to incorrect ordering of transactions. Timestamp allocation. Allocating unique timestamps for each transaction can be challenging, especially in the distributed systems where transactions may be initiated at different locations. So this is about the timestamp ordering concurrency ordering control. Yeah, thanks for watching.